Hello everybody, Mr. Milks back with video lecture number 5 for boot camp. Today we are going to get into the specific classifications of matter and how to do particle diagrams. There will be a third Google Classroom assignment for you for credit at the end of this lecture video. So we need to understand particle diagrams in general and what are some of the things that go into them. So this first row across the top are elements. Okay, I have single atoms, so each sphere is an atom. And notice they're all the same color. So that means that they're the same kind. Okay, and that's how these particle diagrams work. You get some leeway with how you draw them, by the way. But your key needs to be accurately listed, and then you need to be very uh, rigid or follow that key meticulously, please, so that everybody's clear. The second box is diatomic molecules. Diatomic, break that word down, two atoms. So that's two atoms of the same kind that form an actual molecule. We will learn later who these special diatomic guys are. I'll give you an example right now. Oxygen that we are currently breathing is diatomic. An element of oxygen does not exist by itself. It is always paired with another oxygen atom if it's pure oxygen. Okay, so when I see these two diagrams, these are diagrams of elements. Single atoms or diatomic atoms we will call elements. Next line down all the way across, these are examples of mixtures. Notice in each box there's more than one kind of thing. Now we can depict that with color in this example, where in the first box I have orange and I have green. So green is all the same element or same atom, where the orange is all a same atom. And I have two different kinds of atoms in the box, so now I have a mixture. So you can use shape, you can use size, you can use color, you can add patterns when you're drawing yours, right, to distinguish one from another if there's two different kinds. In the second box, I have single monatomic atoms, and I have diatomic elements, like I learned before. I have diatomic molecules in the second, for the third and fourth box. The two little pink dots is a diatomic molecule. They are the same size, same color. Okay, so that gives us information that we're looking for in these. The purple, again, is again a diatomic molecule because those two purple spheres are the same color, same size, so hence the same atom. Two atoms combined together is a diatomic element like we learned. Then we have, in the last box, an actual compound. Compound is more than one kind of atom bonded together to make a molecule. And if I see in this particular picture, not necessarily on your page, but on the picture here in the video, I have green with two red dots attached to it. So that's two different kinds of atoms, plus the green one is larger. So on size and color, I can tell there's two different atoms there making a compound. Okay. Last row, compounds. Again, compound has more than one kind of atom forming a molecule. What I want to talk about the difference between this piece and the piece we were just at is this is a pure compound. Notice everything in the box is the same kind of thing. I see one green and two red or two pinks or reds, whatever you want to call it. Each molecule is exactly the same. So it's not all one element. There are more than one element in that particular container, but each molecule is the same, and that's what makes it pure. Where these two boxes up here are not pure. They are heterogeneous. There is different atoms, but each molecule is not the same. The diatomic pink is not the same as the diatomic purple. So I have two different things going on in that particular box. Same with the diatomic pink with the compound of green and pink. Two different things. This is what makes it heterogeneous. I have two different things in that mixture. It is not pure. Okay? The particulate nature of matter is basically just talking about between separate bits of matter, there are spaces that contain no matter. So this is the particulate nature of matter. There's matter exists, and then there's space in between pieces of matter. And we will depict them in our pictures. Okay, so these particle diagrams let me know about the matter that's there and the space between them, or how is that matter arranged. Now, it might not be so important now, but as we get into to future units, when we start drawing these things on phase, liquid, solids, and gases, the space in between the molecules is all going to change. So we're going to want to keep an eye on not just the molecules or elements that are in a particular particle diagram, but how are they arranged? It's all going to come together and give us lots and lots of information. All right, well, energy happens to act on this matter. The chemistry definition would be the study of energy and matter and how they react. Okay, so there's different energies that are going to react on our matter that we just drew pictures of. Mechanical is one form. We would look at that as the sum of the kinetic and potential energy in a system. We call that mechanical if I take them both together. Thermal energy. Thermal energy is kind of like heat. It's the internal energy of an object due to the kinetic energy or the motion energy in the atoms or molecules. So how hot something is. Electromagnetic energy is anything that can be reflected or emitted through electrical or magnetic waves. So like X-rays, microwaves, radio waves, gamma radiation, the whole spectrum, infrared, of all the different kinds of energies outside of just what we can see, which is the visible spectrum. So this incorporates all of them. For our case and purposes for Regents chemistry, kinetic energy is going to be called the energy of motion. Once we are moving, it is kinetic. Okay, we will further expand on these definitions as we go, but this is a good starting point. Energy of motion is kinetic. The potential is the energy of position, or the stored energy. We're going to learn that chemical bonding has stored energy in there. It doesn't have to move anymore, but it has a potential to do something. Okay, so stored or energy of position or stored energy would be called potential energy. Those are 5 different kinds of energy that we might have to talk about at some point within the year. And that's it. We're done with this video already. Check it out. Google Classroom assignment for today. Make sure all the notes are done from page 17. Hopefully you don't have to rewatch the video too many times to get it all. Complete your online Google Classroom assignment, part of your homework. Come to class prepared to do pages 18 and 21. Let's see how many of those you've tried and how many you were successful to do on your own. And be ready to do the unit's POGIL. This is our first POGIL is coming up, particle diagrams and classifications of matter. We'll be working in teams to complete this activity to further expand and understand how to draw our particle diagrams and what this classification matter business is all about. So thanks for watching, guys. I'll see you tomorrow in class.